I'm the teacher and I'm supposed to know that stuff, but I have no idea.
Tomorrow it says, it does say we have it tomorrow. Third one.
All right. Here we go. Starting a little discussion about polynomials. This is a big chapter. This has a lot of stuff in it. We are gonna have fun. Well, that's because I'm barely. All right, so here we go. At the top there, you see kind of the formal definition of a polynomial function. And some vocabulary. Degree is n, leading coefficient is a sub n. So an example of a polynomial function might be something like this. That's a polynomial function. The degree of the function is 3, and this guy's called the leading coefficient. Now, if the terms are turned around, the degree is still the highest power, and the leading coefficient is the coefficient on that term, right? So we're supposed to have things in descending order, but once in a while they're not. So the leading coefficient isn't necessarily the first coefficient, it's the coefficient on the highest power. And the highest power is the degree, right? Okay, so zero function, right there, the zero function is f of x equals 0. So what is that? What does that look like, f of x equals 0? That is the x-axis, isn't it? Yep. And it doesn't have degree, and it doesn't have a leading coefficient. As opposed to a constant function, which is f of x equals 12, that's also a horizontal line, right? Its degree is 0 because, let's say it is 12. Isn't 12 the same as 12x to the 0? Yes, because x to the 0th is 1. So the degree of that is 0. All right, which of these are polynomials? All right, so what do you think? What do you think about A? You think that's a polynomial function? Yes. We're not going to be alarmed by fractions. Fractions are fine. Rational numbers are fine. What about B though? Yeah. You think B is a polynomial function?
No.
What's stopping it from being a polynomial function?
There's only 2 terms.
It's got that radical on it, and we don't want to have a radical on it. Now, if you could somehow simplify that, so for example, if it were just this, just that, then you can make an argument for that, because what's this the same as? This is the same as 3x squared. But you can't do that with the one that's written there, because remember, if there's a plus or a minus underneath that radical, you don't simplify it. There's nothing to do there at all. That problem is what it is, and it's not a polynomial.
If that was the case, would y equals 3x squared be considered a polynomial?
Yes, yes, that's what we said, yes. All right, what about C? Well, you're kind of at a disadvantage here because I didn't really explain in the definition what n is. Go back up to your polynomial function definition. I said the degree is n, okay, but what kind of number is n? It has to be a positive integer, right? So in other words, it has to be a whole number. So if you have a negative exponent, then that's gonna pop your variable down into the denominator, and it is no longer a polynomial function. Let's think about this for a second. A characteristic of polynomial functions is that they are continuous. we're gonna learn how to graph all kinds of funky things by hand, but polynomial functions are continuous. Remember what that means? Okay, as soon as you put something in the denominator, like in this problem right here, what happens? Now we got an asymptote and we're no longer continuous, right? As soon as you put a radical in your problem, in that one that we had before, as soon as you put a radical in the problem, doesn't that cause domain issues, potentially cause domain issues? And polynomials, their domain is all real numbers. So when you insert a radical, when you insert a denominator with an x in it, you're blowing that. Those are not polynomials. So you cannot have radicals, and you cannot have variables in the denominator, negative exponents. In other words. All right, what about D?
Yeah.
D is a fine problem. That is yes. What is the degree of D? It is 4, and its leading coefficient is -2. Now that leading coefficient, you're gonna find out as we go through more of this, that leading coefficient is going to be really, really important when it comes to graphing, because it's gonna give you the direction of the graph. So like this one started down and came up. Well, sometimes they start up and come down, and that depends on that degree and that leading coefficient. That will help you decide. Okay, f of x equals 13. That is an example of a constant function. It's gonna graph as a horizontal line. Very, very boring. Don't really need to spend much time talking about that. Write the equation of a linear function given this. I love this problem because you'll read it and you think, oh, it's hard, but no, it's not. You've done this since you were like freshmen. What are we doing? Writing the equation of a line. What is this really saying to me? If x is -1, y is 2, and if x is 3, y is -10. So your job is to write the equation of the line containing those 2 points. Okay, what do we need to do?
Find the slope.
Find the slope. I got -3 if I didn't make any mistakes. And then what? Pick a point. Doesn't matter which one. I'll just take the first one. Does that look okay? And then since the directions say linear function, we'll go ahead and write it as a function. But isn't that just the equation of a line? Easy peasy. Nothing to it. Nothing to it. All right, part 3. A little definition there, average rate of change, f of b minus f of a over b minus a. So again, using function notation, so f of b, so like this might be b, so f of b, f of a. Wait a minute, what is the average rate of change then? F of b minus f of a over b minus a. Okay, so think about your functions now. Let this be a and this be b. What is that? That's just the slope, isn't it? That's just the slope. Because isn't this the y value, f of b, and this y value, and then b and a are the x values? So when it says, we'll talk about b in a minute, but let's skip down to c. Find the average rate of change for this function. The answer is rate of change is slope. It's how y is changing relative to x. And in a linear situation, that is just slope. The initial value of a function is f of 0. Does that make sense to you? That if we want the initial or the starting value of a function, we would put in 0 for x. Here it comes. And this is also the constant term. So what that means is, if you look at the function in number C, what do you get if you put in 0? What happens when you put in 0? You just get the constant term, always. You get the y-intercept. All right, easy enough. Oh, Don, come up here, you missed some stuff. Did he get both things? George, did you get both things? The other one was this.
Yeah. I have a quick question on that one. Why did you put in -1 for the y-intercept?
What now?
She's from
For the -3x-1. Like putting in -1 for the y-intercept in the 5 equation.
Where did this come from?
Yeah.
I worked this out. So I distributed -3 and added 2. So I didn't put anything in it, that's just what it came out to be. Point slope. Okay. All right, this next set, I don't wanna get interrupted on. So let's skip ahead a bit, we'll come back and get these other ones, but I wanna wait a second, cause I don't wanna get interrupted on that, it's too much hassle with the calculator. So we'll come back and get 4, 5, and 6, probably after the test. Let's go to number 7. Write the quadratic function in its vertex form, then name the vertex and axis of symmetry. All right, you can do this. First of all, is that a quadratic function? Yes. So its graph will be a parabola. Okay? Now, on your test, you're probably gonna have to graph or discuss some parabola, and it might look like this. When it looks like this, what do we know about it? Right away, we know it's a parabola because it's a square. What do we know about it? It's left 1 and down 3. This point, I don't know if I've been using this word or not, but that point's called its vertex, right? This is called the vertex. And when the equation is written like this, that's easy. Just look at it. This is a parabola. It has a vertex, but it's a little harder to tell where the vertex is when it's written like that, right? You could figure it out, you could plot a bunch of points or whatever, but there are a couple of different ways that you can figure it out. One way is to use the axis of symmetry formula, which you've probably seen before, x equals -b over 2a. That is the axis of symmetry formula. This formula gives you the axis of symmetry of the parabola. Notice that if you know the axis of symmetry, don't you automatically know the x-coordinate of your vertex?
Yes.
So, our job is to find the vertex of this, or write it in vertex form, so basically find the vertex. So, let's find the axis of symmetry. Negative b over 2a, you get 1. So where's my vertex then? I know the x-coordinate has to be 1. Where will the y-coordinate be? Marin?
Would it be negative 5?
Well, it could be negative 5, it isn't, but I mean, there's nothing stopping it from that's that will be the equation. How do we always find y? We know
You
the
plug in
x.
the x.
We're just gonna plug it in. So that's just gonna be negative 3 plus 6 minus 5. I got negative 2. Vertex is negative 2. Now, what do you think that equation looks like? What that equation looks like, if that's the vertex. What do you think its vertex form looks like? Well, we know for sure it's gonna have an x minus 1 squared minus 2. Would you agree with that?
Yes.
That would give me a vertex at 1, negative 2. Does this equation, though, match the one we started with? Do you think if I FOILed this out, you know, wrote it all, expanded it out, would it look like that?
No.
What's missing?
Pardon this interruption, but Father Emmanuel will be saying Mass in 5 minutes if you're available.
Okay, so what do you think? What should we do to make it match that?
3, add the factor of 3.
You should,
Add it?
let's try.
Put it in front of, like, put it in, or
X
like,
minus 1.
yeah, sorry, I'm like,
Put it right here?
Yeah.
Negative 3? Well,
Maybe not.
well, now, wait a minute.
Jinx.
Wait a minute. Go ahead, on your paper there, FOIL this out. FOIL that out.
It works.
That's vertex form.
It works.
So
FOIL it out,
exactly.
collect what terms. Go ahead, do it, come on, hurry up, hurry up, hurry up, hurry up, we got stuff to do. You're just foiling this out. Oh my gosh. They got it right, they sure did. Now, how come they got it right? Think about that for a second. We know that this part of the equation right here controls its position, right? What does this number out in front, what does that have to do with anything? What does that control?
It makes the y
The
units.
wideness of the parabola and the direction of the parabola, right? Whether it's right side up or upside down. So doesn't it make sense that we just need to put a multiplier out here to control the size of that? Well, that's what you do anyhow. So girls, you hit it right on the head. All right, now we're gonna do the same problem quickly. The same problem by completing the square. Because if you look at your vertex form, you need a square, something square. So we're gonna get that, we're gonna make that happen by completing the square. So thoughts on that? How might we go about completing the square? Remember, we'll only do it on the x's. We're not concerned about the y's, they are not squared, just the x's. Yeah.
Would you divide it all by
You know what, you absolutely can. I am not going to, and I'll tell you why. Because, well, it's gonna make a bunch of fractions and I have to divide this by -3 also. Now, it's okay, if you wanna do it, you can. I think what I prefer to do, Sabrina, see if this will work for you. I'm gonna add that 5 to the other side because it has nothing to do with the x's completing the square. And then I'm gonna divide that -3 out of, I'm gonna factor it out. I'm gonna divide it out, factor it out. So I haven't created any fractions, and fractions are fine. You can do what she said, it'll work out just great. But this way I don't have any fractions, so I pull out my -3 just from my x's. Now I left a little blank here because I'm gonna complete the square just on my x's. So what number goes here?
1/2 of -2 and squared.
Okay, so 1/2 of -2 is -1, squared is 1. That needs to be added to the other side too, but remember it's inside of parentheses, so it's not really a 1, it's a -3. So now I have y plus 2.
Wait, why the -3?
-3 times 1. It's inside the parentheses, so it's being multiplied by -3. So combining these, and then I got my square here, which is what we planned. And then if I move that 2 back over, don't I get the girl's equation? So we did the same problem both ways. One way we completed the square, and one way we used the vertex formula, axis of symmetry formula. Now, let's stop and think just a minute. Can I do every problem, every parabola problem with the vertex or with the axis of symmetry formula? Yes, I can. Most kids like this way better. I'm perfectly fine with that. But this is necessary because is every problem in the whole wide world a parabola? No. And this little deal here is only gonna work in a parabola. So when you're given an ellipse or a hyperbola, not in this chapter, but down the road, then guess what? You're gonna have to be able to do this process. So you might wanna practice this a couple of times, even though it's perfectly okay to do it this way. All right, one more problem and then we're done till lunchtime. The Welcome Home Apartments has this much. All right, so you're gonna write your own equation. All right, guys, read the question again. The total rental income. Would you agree? Well, wait, how does this complex find income, get their income? Number of apartments we rent times what?
Price.
The amount of rent, right, or the value of the rent? I don't know if I worded this very well or not, but this is the number of apartments times the rent we charge for each. Isn't that how we find our income? Okay, so in the beginning of the whole problem, in the very beginning, how many were we renting? 800. But that's changing. All right, hang on to that. How much was each rent? What was the rent for those apartments? 300? But that's changing too. So right now, the company would find their income by taking 800 times 300. right? But what's changing? What's happening? The
price,
the price is decreasing. So the price is going down by how much?
$5
5x.
Not per month.
per the amount of time they want to do it.
Okay, so let's let X be the number of price decreases.
Yep.
Every time they change the price, it goes down $5, right? Now, what happens to the number of units they rent?
Plus 20,
Plus
It's
20x.
going up
20x.
in increments of 20. So when they lower the price, they rent more units. Does that make sense to you? Yeah, that's basic economics, right? They lower the price, they rent more units. Does it also kind of make sense to you though, that if they just keep lowering the price, eventually they're not gonna make any money? So there has to be, we're looking for that fine point where we lower it just enough to get the most people renting and maximize our income. Oh, wait, maximize our income. If you were to FOIL this out, what kind of equation would this be?
An upside down
There's the X there.
Okay, there. I was
Yeah,
wondering.
sorry about that.
parabola. Negative parabola.
It'd be a parabola opening down. And if we wanna maximize it, we just wanna find the vertex, right? Now, there are a couple of ways we can do that. Dang, I gotta get this time better. All right, so there are a couple of ways we can do that, but we're gonna have to talk about those when we come back. Sorry about that. Because I want you to get to lunch on time, and I want you to come back on time. So I need you back in your seats at 12:30. In your seat at 12:30. We'll finish this up, and if you have any last minute test questions, you need to bring those too.
I'm so excited.